Now I'd like to show you a large collection and the impact that indexes can have on performance. So I've loaded up 10 million documents into a collection, and I'm going to show you that in the Mongo shell. It's in the school database, in the students collection, and I'm going to look at a single document in the collection, which is a great way to get an understanding of what the data looks like, assuming it's regular, and it is in this case. So you can see each document has a student ID and a bunch of scores for the student. These are 4 assessments: an exam, a quiz, a homework, and a homework. This is the grades they got in this particular class. And so there are 10 million documents, so there's 1 million students that have each taken 10 classes. Now there's absolutely no indexes on this collection. So let's see how long it would take to do a query on this collection and try to find all the information for student ID, let's say 5, which should be very early in the collection. Since we just inserted it, it was probably inserted in order on the disk. And I'm running the mmap v1 storage engine in this case. All right, let's do that. All right, that took a few seconds to return those 10 documents. And this is a fast computer. This is a 4 gigahertz Core i7 computer with 32 gigabytes of memory and a Fusion drive that has a combination of SSD and spinning disk on it. So that's a long time. That's a lot of cycles for a computer this fast. So the question is, how can we make it faster? But before I do that, I want to show you a couple of things. First is that there is an explain command that we're going to go over in a later lesson that will show you the secrets of what the database is doing when it executes a query. And I want to give you a little foreshadowing of this command. It runs on top of a collection. So db.students, students is the collection, explain is the command, and then you chain what you want to do. In this case, you want to do a find. You can also chain an update or a delete. And it's going to tell you what indexes it would have used to satisfy this query. Now, in this case, there aren't any indexes it can use, and it's going to scan all 10 million documents, and it should tell us that. So if we look through the output of explain, and we'll go through it in more detail in a later lesson, the interesting part is right here in the winning plan section, where you can see it says it's doing a collection scan. It's looking at all the documents. And that's going to be pretty slow. Now, if we actually did a find one versus a find, then it'll be faster. And the reason it'll be faster is that once it finds a single document, it can quit looking. And so since the documents are probably in student ID order approximately right now, that's going to be fairly fast. And you can see that was fast. Didn't take very long for it to return a single document for the student ID 5. But we want a general find to work well, so we want to add an index. So how do we do that? Let's add the index, db.students.createIndex, and you'll notice it's camel cased inside the shell, lowercase c, uppercase I. And now we're going to present the document to createIndex that describes the index. And in this case, we're saying we want it to be indexed on student ID ascending. We'll talk a little bit more about what that means later. But we're going to hit return, and it's going to take a while, so I'm going to time this off camera so that I can tell you how long it took on this super fast computer. Here we go. Okay, it took about 23 seconds on this computer to create this index. And that's important to note because even on a really fast computer, creating an index takes a while because we have to scan the entire collection, create new data structures, and write them all to disk. All right, now that we have an index, this search on finding all the students with student ID 5 should be nice and fast. Let's see if it is. Woo, nice and fast. And it was. And if we run the explain command, we're going to see that it's now using an index. So let's see that. All right, so I ran the explain command once again, and you can see now it says the winning plan for this type of query is to use the index name student_ID1. And that's fantastic. And one little other secret I'll tell you about explain is that if we give it true, and there's 2 ways to give arguments to explain. This is actually the older one. Then it'll actually run the query as well, which means it can tell us how many documents it actually looked at in the execution stage of the query. And you can see that number of documents examined was exactly 10. Isn't that pretty cool? So once it used the index, it only had to actually look at 10 documents. Wow, that's fantastic. All right. Now we could also add a compound index to this collection. And if we wanted to add a compound index, we would do it as such. We would give a second key and then ascending or descending. So for instance, this is the command you would give to create an index on student ID, comma class ID where the student ID part was ascending and the class ID part was descending. And this won't affect the queries we just did, but it will affect things like sorting, where if the indexes aren't in the right order, and depending on how you specify the sort, you may not be able to use the index. Okay, so now it is time for a quiz. Please provide the Mongo show command to add an index to a collection named students, having the index key be class, student_name. And neither of these will be in the -1 direction. Type your answer right here.